Okay, sorry, I got another robocall, which is awesome. So let's do this. Let's get into the math of things. The math around pH can be easily written as the log of the concentration of positively charged hydrogen ions equals negative pH. Right? Isn't that beautiful? I mean, it's got everything we want. And this, just to be super clear, is the concentration of hydrogen ions. Hydrogen ions. So, everything students love. They love talking about concentrations of things. They love talking about logs, and they love negatives. Yay! Isn't this super fun? We are so excited about the next couple minutes. I can't wait. So we're going to pick this thing apart. So I'm going to write it up here. And we're going to pick it apart and see if any of this makes sense. Now, here's the thing is, I'm going to show you a trick at the end of the video so that you do not have to actually understand the math. So if you want to just kind of phase out for a little bit, sing songs in your head and that sort of stuff, now's the time. I'll tell you when to click back in. Okay, we need to figure out what a log is first. So to play with this, let's pick a pH. And I'm just going to pick the pH of 3. So we're just going to substitute 3 in for pH. And then we'll kind of backfill everything else. So it's a negative pH in my formula up here. And we have the log of the concentration of positively charged hydrogen ions. Okay, so I've just chosen 3 randomly. It could be anything between 0 and 4. It can have a decimal. It could be 1.73, but I just chose 3. First thing is, there's usually a number down here with log. You'd see 2, 3, 17, whatever. If there isn't, then a 10 is implied. So up here, there's a 10 implied there. So I'm just going to write it in so we can be super clear about this. And what does log mean? Log means whatever this number is, which is usually written unless it's 10. So if there's nothing there, it's a 10. This number raised to that power equals this. What the... Man, we got off the rails fast there. So what that means is I could write this another way. I could say 10, which is this number here, to the, well, whatever's over here. I have a negative over there, and I have a 3 over there, equals the concentration of positively charged hydrogen ions. So to write this easily, we just say log of this equals that, right? But to really write it out, all this says is 10, which is implied because nothing was written next to log. 10 to the negative 3 gives us this number. Okay, so what does 10 to the negative power mean? Oh, that's right. Thinking way back into algebra, I remember that anything to a negative power is just 1 over it. So I could write this negative, I can just say it's 1 over, again, my 10. And now it's not negative 3, it's 3. I took care of the negative by putting it under 1. And that is the concentration of positively charged hydrogen ions, which I wrote backwards here and almost wrote backwards again because I'm that kind of smart. And so then we can simplify this and get a nice little answer of 1 over, and what's 10 to the third? Well, that's going to have 3 zeros, right? So it's 1 with 1, 2, 3 zeros, so that's 1 over 1,000 equals the concentration of positively charged hydrogen ions. So what does that tell us? What that tells us is if we have acid and they have their acidic hydrogens because they're ready to go and they're still called acids. If they didn't, they wouldn't. And I have 1,000 of these acid molecules. One out of the 1,000 is going to say, take that, take my acidic hydrogen. And it's going to no longer be an acid, and it's going to float along, doing its thing, but not being an acid anymore. 1,000th of them will react. 999 say, it really ties the room together. I'm gonna hold on to my acidic hydrogen and not react. And it continues on, still being an acid. So what this says is that one will react and no longer be an acid out of 1,000, and all the other ones don't. Okay. That is the math. Now let's do the shortcut. So if you've been singing songs in your head or taking a little nap or anything like that, now's the time to kind of come back. We can talk about the concentration of hydronium ions with this. And here it is. Nice shortcut right here. Ready? I'm going to make a little grid because people love grids, and we'll just kind of fill in a couple answers. We're going to put pH. And then what we're going to do is we're going to do the concentration of hydrogen ions. So that would be the concentration of positively charged hydrogen ions. And that's the number that goes here. So in our last example, that was 1 over 1,000 if this was 3, or -3 is the whole thing. So let's say that, I don't know, I've got 2. Well, that makes this a 2, makes the whole thing a -2, so 10 to the -2, and so the 10 drops down to the bottom. Oh, geez, this is getting hard fast. Let's see. We've got 10 to the -2 equals H plus, and that means 1 over 10 to the 2 equals H plus, and that means 1 over 100 equals H plus. Okay, so it'd be 1/100th. I kind of like this form. Let's just write it like that. 10 to the -2. Okay. So all I did was I took that 10, I raised it to that power, and that gives me the concentration of hydrogen ions. Okay. I just wanted to show you how that relates to the math. Now we're not going to do math anymore. We're just going to do the shortcut. Okay. Well, let's say I have a 10. Well, that would be 10 to the -10, because this is the pH. So I substitute right in there, and that means that H plus equals 10 to the -10. Okay, what if I have, 5? I throw that in there, and I get 10 to the -5. And what if I have 8? -8, 10 to the -8. And hopefully you're starting to see a trend here where you say, wait a second, what if pH was X? The answer is 10 to the -X. That's it. pH is just shorthand for 10 to the negative. So if I have pH of 2, it's 10 to the -2. If I have pH of 10, it's 10 to the -10. If I have pH of 5, it's 10 to the -5. pH of X is 10 to the -X. That's the concentration of positively charged hydrogen ions. pH is literally just shorthand for raise it to 10 to the negative. That's it. So whatever number's here, just write 10 to the negative, and you get it right. So for those of you who don't love math and don't want to get into how it actually works and what any of this actually means in the real world, just raise 10 to the negative number. So whatever I give you here, just write 10 to the negative that number, and you'll do fine. So you may want to pause the video for a moment and write this chart because it's super helpful. Welcome back, because I'm sure you did that. And now let's answer the point and get out of here. How does the pH of acids and bases relate to 7? Well, if I remember correctly, looking back at the graph, acids have a pH of less than 7, all the way down to 0, and bases have a pH of more than 7. And last but not least, a substance with a pH of 7 is neutral, neither. And that means if I add an acid and a base together and they're the right strength and right concentration, their pH would become 7, which kind of makes sense. If it's 7 in the middle, if I'm this far and I add them together, they'll meet back in the middle at 7. There we go. Just let this wash over you. We're going to talk more about pH math tomorrow. So if you don't get it, that's fine. I'm going to go over this all over again in another video. Have a good one.